Okay, welcome back to McNab Chemistry. Today we're going to have a look at some common errors that take place when people are answering endothermic and exothermic GCSE exam questions. Okay, today's questions have come from the Educate formative assessment resource. Okay, so the first question where issues arise comes from this first point 1 question. The question was, photosynthesis is a reaction in plants that produces carbohydrates from water and carbon dioxide. It requires energy from sunlight. Okay, is this an exothermic or an endothermic reaction? Okay, well, if you think about this, the sun shines, generates a lot of light energy and heat energy. That light energy and heat energy is then taken into the plant to help the chemical reactions of photosynthesis happen. Okay, so the energy is taken into the plant, so the reaction is endothermic. Okay, point 2 question. Which of the following is not an example of an exothermic reaction? Combustion, electrolysis, or neutralization? Okay, well, combustion is most definitely exothermic because it gives out a lot of heat energy. Neutralization is also exothermic. The only one then that's left is electrolysis. Okay, and if you think about what electrolysis is the process of using electrical energy to break up a compound. Okay, so electrolysis is using electrical energy to break up a compound, so therefore really it's the actual process of electrolysis is nothing to do with heat energy changes. Okay, so combustion is exothermic, neutralization is exothermic, making electrolysis not an example of an exothermic reaction. Right, point number 3 question. Which of the following is an example of an endothermic reaction? Now here we haven't actually got the list of the types of reaction, but it's worth just noting that thermal decomposition is an endothermic reaction. Okay, so it's an endothermic reaction because heat energy is taken into the reaction to break up the compound. So thermal decomposition is using heat energy to break up a compound. So heat energy is taken into the reaction, making a thermal decomposition reaction an endothermic reaction. Okay. Next question, point number 4 question. Okay, what name is given to a reaction that takes in energy from the surroundings? Give the full name. This is an endothermic reaction, so remember that endothermic reactions take in energy from the surroundings and the energy goes into the reaction. Okay, and because they take in energy from the surroundings, it makes the surroundings feel cooler. Okay, and this is backed up by the point 5 question here. Would the temperature of a reaction vessel, so let's think about the reaction vessel. The reaction is actually taking place inside the reaction vessel. Okay, so would the temperature of a reaction vessel during an endothermic reaction increase, decrease, or stay the same? Well, in an endothermic reaction, heat energy is going into the reaction, and the reaction is taking place inside the reaction vessel. Okay, so therefore the temperature of the reaction vessel would decrease because the reaction vessel is effectively the surroundings. Okay, so energy is going into the chemical reaction which is taking place inside the reaction vessel. Okay, so therefore the temperature of the reaction vessel will decrease. Okay, the next point that arose came from this question. Okay, so our 6th point that arose from this exercise. Students carried out a circus of 5 different reactions. The details and results are shown in the table. What word should go in gap A? Okay, right, so the experiment is we're adding water to anhydrous copper sulfate, so that's copper sulfate without any water in it. It's a nice white powder. Okay, the start temperature is 15, the final temperature was 19. Okay, so my temperature is increased, so therefore the reaction must be exothermic. So A is exothermic. Okay, so the answer is exothermic for this one. Let's just go through the remaining reactions here, just to reinforce the idea of what happens to temperature in endothermic and exothermic reactions. Okay, so here adding zinc powder to copper sulfate solution. Okay, the start temperature was 19, the final temperature was 26, and my temperature's gone up again, so that's an exothermic reaction. Dissolving ammonium nitrate in water, start temperature 22, final temperature was 13, so my temperature has gone down, so that's an endothermic reaction. Adding concentrated sulfuric acid to sugar, start temperature 18, final temperature 37, so my temperature has gone up, so that's an exothermic reaction. I'm reacting citric acid with sodium hydrogen carbonate, start temperature is 23, final temperature is 20, so my temperature has gone down. Okay, so therefore it is an endothermic reaction. So to conclude from this, if your temperature goes up, the reaction is exothermic. If the temperature goes down, the reaction is endothermic. Okay, number 7 and 8. Right, so next point that came up, in a reversible endothermic reaction, hydrated copper sulfate is converted into anhydrous copper sulfate and water. Hydrated copper sulfate is copper sulfate with water in the crystal. Okay, and anhydrous copper sulfate is a white powder with the water having been removed from the crystal. Okay, and it's telling us that this reaction is endothermic. So what would you expect the reverse reaction to give out or take in energy? Well, if going from hydrated copper sulfate to anhydrous copper sulfate and water is endothermic, that's going in one direction, surely you would expect the reverse direction to be the opposite to endothermic. Okay, so that's an exothermic reaction, so we'd expect the reverse reaction to give out heat energy, because we would expect it to be exothermic. Okay, point number 8, which of the following is not an example of an exothermic reaction? Combustion is exothermic, neutralization is exothermic, electrolysis is neither exothermic nor endothermic. Okay, it uses chemical energy to break up a compound. Okay, the next question that created a little bit of an issue was this idea about round heating up a can. Okay, so the diagram shows the basic idea behind a self-heating can. Where is the beverage to be heated stored in the can? Okay, I think the problem with this is it's quite hard to understand the diagram. Okay, so here C is my fuel. Okay, that's basically the substance or the chemical reaction that's going to give out heat energy, which is going to be used to heat up the liquid that's in the can. Okay, once we've generated this heat energy, that heat energy then needs to be spread all the way around the can. Okay, so part B here, it's like having a coat around the can. Okay, so C releases heat energy, it causes the coat around the can B to heat up. Okay, and A is the can that's inside the coat that warms up. It's like an electric blanket around the can. Okay, except it's not electric, it's a chemical heated blanket around the can. Okay, so what's the question? Where is the beverage to be heated stored in the can? Well, it's stored in A. C is the part that gives off the heat energy, the chemical reaction that gives off the heat energy. It causes B to heat up. B is like a blanket around the can, and the drink goes into A. Okay, so that's a good little bit of understanding of how self-heated cans work. Okay, and then finally, okay, a good bit of neutralization chemistry here. Sodium hydroxide reacts with hydrochloric acid. Right, sodium hydroxide is a strong alkali. Hydrochloric acid is a strong acid, obviously. Okay, but when you put the two together, you get a neutralization. And will the temperature of the solution increase or decrease during this reaction? Well, we know that neutralization reactions are exothermic. That means they give out heat energy. So what effect does that have on their surroundings? This has come up before, hasn't it? In exothermic reactions, the temperature of the surroundings increases. Okay, so my surroundings are the solution. Okay, so the solution will increase in temperature. Okay, so thank you for watching. I hope that has been helpful. Don't forget to like and subscribe and click on the bell notification to stay fully updated.